All right, here's the pad for the big greenhouse being poured. This is the one that'll have the radiant heat in the floor, as you can see there. First time doing this type project with the radiant. Been wanting to do it for a long time, just never had the right project, and hopefully this will be it. So hot water will be pumped through that white pipe right there, which will warm the slab and hopefully warm the entire greenhouse. All we did was take that, this is a oxygen barrier PEX pipe, and just took some hog fencing, and you can see we just tied it to there to hold it down while they pour the concrete and keep it evenly separated out. We did 1 foot spacings, and that is 3,000 linear feet of oxygen barrier PEX. So we ran we bought them in 300-foot rolls because that's as far as you want to go with 1/2 inch before you lose too much heat. It's 300 feet, so you can see we'd go to run the 300 foot out and then go right back here to the main area where the pumps and mixing valves and any other thermostats, all of our main controls will come back here to the back of the greenhouse. Here is our panel inside the greenhouse. Just wanted to show you the manifolds and how this thing actually works. So coming from the stove, you've got your hot line, which is this one here, coming in, and it goes along the floor over here to this heat exchanger. So it comes in the bottom and then comes out the top, goes up into a mixing valve. So this is where our straight hot water goes to the mixing valve, where it's mixed with the cold water coming back from the floor. And so here's where you just take the cap, turn it upside down, click it down on that little triangle, and you can turn it right or left to adjust the amount of cold going back so that you don't get too hot of water, because our tank can produce, well, we've got it set at 160, but we don't want 160. We want about 120, which is what we got there going in. So anyway, the hot goes there, mixed with the cold returning, and then it goes to 2 pumps, one for each zone that splits the greenhouse. So half of the greenhouse is zone 1, the other half, of course, is zone 2. The cool thing about this system is this heat exchanger. So as the hot passes through it, you can then use this to heat other water. So when our city water, which is potable water, drinking water, comes in, we simply just run it through the heat exchanger, and we can go to sinks, and go to whatever you want, wherever you need hot water. In this case, we're going to go to sinks, and also it will go to the irrigation, which will be overhead, ran down to the plants. So pretty awesome deal there. You can heat the greenhouse through radiant in the floor, and then you have essentially free hot water for your plants and your uses in your sink. The only negative to this is during the summertime, of course, you're not going to be burning your stove, so unless you do, you're not going to have hot water for your sink and plants. But for us, that's not going to matter a whole lot. Anyway, you can see these 2 Taco 0015 E3 pumps, and they simply just go into a manifold right there. Shows you how much water flow we've got going through each pipe. So this is one whole zone right here that you're looking at. The red obviously is supply, blue is return, and so you can adjust your flow for whatever purpose. You know, if one area might be getting too hot for whatever reason, you can simply come over here and cut that flow down and cool that zone. So pretty simple. It doesn't look it from this view, I know, but you know, the whole concept is pretty simple. Just heating water, pumping it through pipes back to the tank where it gets heated again, and then we just do that over and over and over. Each one of the pumps are turned on by a thermostat. So what we did was run a thermostat wire to this receptacle, and so that runs all the way around here to this all-weather thermostat. So I've got it set on 80, but that's what turns the circulating motors on and off. Okay, I'm gonna show you now how it goes from the actual stove over to the building. You can see we come out the bottom of the stove there, we trenched over, and of course we did this before we poured our slab, but we just stubbed up right through the slab, and this is looks like a 6-inch really well insulated pipe. I think that's really the key to not losing too much heat as your water is going to the heater or to the heat exchanger, and then obviously returning to the heater. You want to keep that as insulated as possible to minimize your heat loss. It's less work for the stove to do. So here is our supply and return line we looked at earlier, and we just use some simple strapping. Strap it to the building, and then that goes up to some brass elbows, and then inside the building to the pecs. So simple as that. And then we'll silicone around it to keep it from leaking, and put some insulation around that those brass fittings. All right, so like we said on the outside, our stove is gonna, of course, heat the greenhouse. And then we said we're gonna go inside the store and help heat it as well. So here's our heat exchanger that is gonna be installed, which Art's cutting now in the air handler right there. And so that'll just slip kind of like right in there, Art, or how is it attached inside?
What we did was, give me that thing on the ground right there. I'll show you. So these plenums were already here, so we split them open to take the size of the exchanger we have. We'll put these brackets in here, screw them down, and that'll allow the exchanger to be slid in and out in case it has to be removed.
Oh, okay, so easy in, easy out.
Yeah.
I like that. Pretty simple. And so then hot water will just pump through the heat exchanger, and as the fan for the unit is running, it'll just pump it right out the ductwork and into the building, correct?
Yes, sir.
That's simple enough. And what's the temp of the water to be going through the exchanger?
About 160 degrees.
All right, cool. So 160 degrees coming from the stove through the heat exchanger, and then simply air is just pushed across that and distributed throughout the building, hopefully saving us a bunch of money on our electric bill.
That's right.
All right. It's a lot easier than I had anticipated. We were just outside looking where we're going to bring it through the wall right over there. Come up about, I don't know, 12, 15 feet or so. And you say you're going to come through it with stainless nipples?
Yes.
And then you're going to change over to what to get it to the exchanger?
Pecs.
Pecs. 1-inch pecs. All right. Cool. It's an exciting day here today, guys. We finally get to put a fire in our Crown Royal 7400 MP wood burning boiler. So we've got it ready, a little bit of wood in there, and as you can hear, filling it up with water. So also got fans going on the greenhouse. Come on, you find Art. Here comes our buddy Art with clean sweep, right?
Clean sweep?
Yeah, clean sweep. Out of Newberry, South Carolina. So Art, I just telling the folks, we got her filling up with water. Got us a little pile of wood in there we're gonna light up here in a little bit and see how this thing works. I've been wanting to do this for how many months now?
I know. I had the valves on. You could have shut the valves off and started a fire for funsies.
I was going to, but I said, no, if I could, then hey, this is my fat one. And so the fan cuts on when?
When it reaches your set temperature, when it drops below what you got to see that.
Something's running now.
Just keep going.
It'll take most of this big stuff too. This one's probably a little bit too long. Yeah, that was there now. This thing is deep.
There you go. Yeah, that's $6 right there.
Yeah, hay prices are sure is, ain't it?
Got it now.
Took it in, probably.
I know. There's some nice ones now, look at them. Alright, so the fan's on, and it's going down from the
Top
top.
fan's on.
So which one is this one? This, you said this is the bottom?
The primary, yeah.
Primary.
The bottom one's
Okay.
adjustable, the top one's not.
And so why wouldn't you want to put it on high when you're trying to get it?
So usually you'd run it on high like if you're burning greener wood
Yeah.
when you need more air, but it's kind of like a carburetor. You're looking for a good fuel to air ratio.
I got you.
So usually set it about 2 o'clock.
Okay. And then so the top fan is automatic, you say?
Yeah, and it's single speed.
Okay. So what temperature do we want it to kick on at? The top fan.
Well, they both come on together.
Oh, okay.
That just controls the speed on the
Speed
bottom
of them
fan.
both.
Yeah.
Oh, just on the bottom fan.
Yeah.
That's pretty awesome, man. Oh, do I need to put the plug back in top?
You can, but it's probably
Already
gonna
did.
push some water out to start with.
Yeah.
Already did.
Oh, you did? Oh, he already put it in. Okay. So we
Oh,
just
you
watched
talking about
that.
that.
How often do we have to fill it? I mean, what kind of water loss will we have?
Couple times a year.
Oh, that's it.
And when you fill it, you'll put maybe 4 or 5 gallons in.
So that's pretty minimal loss.
Yeah. Since it's an open system, it's really just evaporation. You don't get any, it doesn't boil or.
It's got nowhere else to go. So you're just losing evaporation, so it will just be coming out of the...
Now, if you took the same stove and you put it where the pumps turn off, so the stove sits here and idles, it'll push a lot of water out. But with the pumps running all the time, you don't use it a whole lot.
Cool. Do you have any idea how long it'll take to get that up to temp? Have you ever started one from dead cold like this?
If you got good warm, good dry wood, it'll probably be up to temp in an hour.
Really? That's a lot of water.
Might take a little longer, but got good dry wood.
Oh yeah, it born a little bit old.
Let's see, you started at 55 degrees.
Okay. 55 degrees at 12:15. So we'll see how long it takes to get. Now, the smoke that comes out of the stack, we can control that as well. You know, I mean, if you were to turn the fan, like say you wanted just to run it super hot, you know, if you're in a more residential area or something like that, you wanted minimal smoke. Is there a way to achieve that, or is it just kind of depends on what you're burning?
Once it gets up to temp and you're burning dry wood, you won't have any smoke.
So our fan has cut off because we got up to 160, so it'll get down to 150 and it'll kick back on. And it's been working very efficient so far. Only had to fill it, well, we did fill it twice yesterday, but that's only because we were burning some of these chunks right here. And they burn up pretty quick because they're dry. So we need to get us a bed of coals. So I went and cut some green wood, and we put that in there to try to help build up a bed of coals, and then it'll should stay. I think we only got to feed it once a day. Let's see if this door is unlocked. Hey, good deal. So look at the size of this store. And this is a lot of airspace to heat. Big tall roof. We did install us a fan up there to help push the heat down. One of the very low energy, slow turning fans. There's our 2 runs of ductwork coming from the 2 air handlers. But I mean, it's probably 75 in here now. I had to turn it off because I didn't want it to get too hot. Let's go upstairs and see the finished product of Mr. Art's install of the heat exchangers. Kind of show you where we came through the building too. You saw outside. This is where we just punched through. You see the brass nipples there. Then it went right back to 1-inch pecs. And we just kind of laid it right on the floor. Let's see, look at the size of this building. I'm really impressed that it's throwing out this much heat. And it's hot up here. So there's your heat exchanger, and he had installed that up there in case we get any air in the system, which we purged it and got all the air out, so it's just nothing but water. There's your heat exchanger. It's got it all sealed up, so whenever that fan cuts on in there, it just blows the air right across that radiator like heat exchanger, and hot air comes out the ductwork. So pretty dang simple. Awesome little project though. It's gonna save us a lot of money, I can tell already. So really happy with the way this turned out. So anyway, used a Crown Royal stove, Art with Clean Sweep here in Newberry, South Carolina. Did all the rigging and plumbing, and there you have it. That's how you use wood to heat your building and save money on electricity.